Hi my dear student friends, welcome to ACE Engineering College YouTube live session and which is meant for revision series for university examinations, and topic is Laplace transform, which we are continued. The last two sessions we have on Laplace transform, the continuous of the last part here. So in the last part, Laplace transform of special functions I have already discussed this one. So once I will give the review. So Laplace transform of special functions, unit step function, and unit step function means the function which is defined as 0 for t less than 0 and defined as 1 for t greater than 0, and its Laplace transform is 1 by s. Okay, and its Laplace transform is 1 by s. Laplace transform of unit step function. Next, Heaviside's unit step function, u of t minus a. U of t minus a. U of t minus a is defined as 0 for t less than a and defined as 1 for t greater than a. This is Heaviside unit step function, and Laplace transform of Heaviside unit step function is given by L of u of t minus a equals to e power minus as by s. Okay, with the combination of Heaviside unit step function, we are taking one function g of f of t minus a. With the combination of Heaviside unit step function, I am taking a function f of t minus a whose Laplace transform is given by e power minus as into a bar of s, which is what? Second shifting theorem. So second shifting theorem is L of f of t equals to a bar of s, and where g of t is defined as 0 for t less than a and f of t minus a for t greater than a, right. Then Laplace transform of g of t becomes as e power minus as into a bar of s. This g of t is a function f of t minus a with association of Heaviside unit step function. So what? This second shifting theorem I have discussed under special functions, right. So this I have already discussed in the previous session. Just I am recalling, even this also I discussed, otherwise we will see this one, cos of t minus 3 u of t minus 3. Okay, so here which is like f of t minus 3 u of t minus 3, which is like, okay, f of t minus 3 u of t minus 3. Then Laplace transform of f of t minus 3 u of t minus 3, where u of t minus 3 is a Heaviside unit step function. So in such case you have e power minus a 3, a is here 3 na, so minus 3s into a bar of s, Here what is f bar of s? Here f bar of s equals to L of f of t. Here what is f of t? F of t minus 3 is cos of t minus 3. Here f of t minus 3 equals to cos of t minus 3, isn't it? Cos of t minus 3. Okay, cos of t minus 3 into u of t minus 3 I am taking as f of t minus 3 into u of t minus 3. So f of t minus 3 is equals to cos of t minus 3. Then f of t equals to what it becomes? F of t is simply cos t. So then L of cos t is equals to s by s square plus 1. S by s square plus 1 as per the standard formula of Laplace transforms. Laplace transform of cos t formula is s by s square plus 1, which I have discussed in the beginning. So which is f bar of s? Right. Now Therefore, L of cos of t minus 3 into u of t minus 3 is equals to e power minus 3s, minus as means e power minus 3s into f bar of s means s by s square plus 1. Okay. So, this is Laplace transform of cos of t minus 3 into u of t minus 3, which is I discussed by second shifting theorem. Second shifting theorem. By second shifting theorem. It is a problem under second shifting theorem, right. So, similarly one more sum we will see. So, here L of e power minus t into sin of t minus pi into cos u of t minus pi. Okay. What is given? L of e power minus t sin of t minus pi into u of t minus pi. Even this problem is also looking application of second shifting theorem. Okay. So, here we have extra e power minus t na. When a function means if I take this as a function, when I take this as a function and multiplied by e power minus t by first shifting theorem, which is the problem is application of first shifting theorem and second shifting theorem. So, L of sin of t minus pi into u of t minus pi, where s shifted to s plus 1, where s shifted to s plus 1 as e power minus t exponential function combination is there na. So, then when I remove means when with respect to exponential function, then the Laplace transform of the remaining function is with s plus 1, v is with s plus 1 means where s is shifted to s plus 1. So, now which is like L of f of t minus pi u of t minus pi, which is like, okay. So, means second shifting theorem where s is shifted to s plus 1. So, which is equals to e power minus pi s into f bar of s, where s is shifted to s plus 1 by second shifting theorem, okay. By second shifting theorem we write like this, but what you have to find f bar of s, here f bar of s equals to, otherwise I will go for next. So, here I have to find f bar of s. F bar of s means L of f of t. So, where f bar of s equals to what? F bar of s equals to what? L of f of t. Okay. So, what is f of t here? F of t minus pi is equal to sin t minus pi. Then f of t is sin t na, L of sin t. Okay. F of means f of t minus pi, in the place of f of t minus pi we have sin of t minus pi. That implies f of t becomes sin t. F of t becomes sin t. Therefore, L of sin t becomes as 1 by s square plus 1 as per elementary standard formula. As per elementary Laplace transform of elementary functions, we have 1 by s square plus 1. This is f bar of s. Okay. This f bar of s you substitute here. Here you substitute, which is equals to e power minus pi s. F bar of s is what? 1 by s square plus 1, where s is shifted to s plus 1. isn't it? F bar of s is 1 by s square plus 1. So then e power minus pi s into 1 by s square plus 1. So where s is shifted to s plus 1, which is going to be e power minus pi s, so which is, this is equals to e power minus pi s pi into s plus 1, where s is shifted to s plus 1. So s, in the place of s I am shifting by s plus 1. So e power minus pi into s plus 1 into 1 by s plus 1 whole square plus 1. I am simplifying this, e power minus pi into s plus 1, 1 by s plus 1 whole square is 1 by s square plus 2s plus 1 plus 1, that is plus 2. So therefore Laplace transform of e power minus t sin t minus pi into u of t minus pi is going to be e power minus pi into s plus 1 by s square plus 2s plus 2. Okay. So these are the applications under second shifting theorem. So this problem is both second shifting theorem and first shifting theorem, both. So this is by happened first shifting theorem. This step I wrote by using first shifting theorem, how s is shifted to s plus 1. Okay. Next Laplace transform of some special functions, that is periodic function. Periodic function. So definition of periodic function, sometimes they are asking for the short answers. A function f of t is said to be periodic function if there exists a constant t greater than 0 such that f of t plus t is equal to f of t. Okay, for all values of t, that is f of t plus capital T equals to f of t plus 2 capital T and so on is equals to f of t, then the function is said to be periodic function with a period capital T, means the function is attaining itself over a periodic capital T. So then it is Laplace transform of periodic function, Laplace transform of periodic function, that is L of f of t equals to 1 by 1 minus e power capital Ts, period of the function, integration over 0 to capital T into e power minus st f of t dt. So this is Laplace transform of a periodic function. I have given the definition of periodic function and its Laplace transform. Okay, so Laplace transform of periodic function is 1 minus e power minus capital T into s into integration over capital T into e power minus st into f of t dt. This is Laplace transform of periodic function. Okay. So sometimes they are asking for short answers, short answer type. So make it note of definition of periodic function and its Laplace transform. Next, now I am taking a period, okay, one function I am taking, that is f of t equals to sin t over the interval 0 to pi, f of t is equal to 0 over the interval pi to 2 pi. So for this asking us find the Laplace transform. So here f of t is a periodic function with period 2 pi, that provided in the problem. F of t is a periodic function, of course sin t is a periodic function with 2 pi, that we know, right. So now here f of t is a periodic function, f of t is equals to sin t, is a periodic function with period 2 pi, with period 2 pi. Okay, right. So means here capital T is equals to 2 pi, capital T is equal to 2 pi. Then L of f of t means f of t is a periodic function is equals to 1 by 1 minus e power minus capital T into s integration 0 to capital T e power minus st f of t dt. So, this is Laplace transform of a periodic function where f of t is periodic function that I said, right. Now, here L of f of t is equals to 1 by 1 minus e power minus capital T s 1 by 1 minus e power minus capital T s integration 0 to t integration 0 to capital T. Here t is what? Here t is what? Here capital T is equal to 2 pi. Here capital T is equal to 2 pi, right. So, now, so here in the place of capital T you write 2 pi. So, 2 pi and 0 to 2 pi e power minus st into f of t dt. Okay. So, as per the Laplace transform periodic function I wrote the form. So, which is equals to 1 by 1 minus e power minus 2 pi s. So, here integration 0 to pi e power minus st f of t is defined by sin t over the interval 0 to pi over the interval 0 to pi. So, I am writing sin t plus actually the interval is 0 to 2 pi now. So, from 0 to pi function is defining as f of t, from pi to 2 pi e power minus st into what is f of t, pi to 2 pi f of t is 0. So, that I am writing into 0 into dt. Okay. So, which is equals to 1 by 1 minus e power minus 2 pi s. The last integration is going to be 0 as its function is 0. So, this term is going to be vanish, only this will be left, that is integration 0 to pi e power minus st sin t dt. Okay. So, this integration we have to find. So, which is equals to, otherwise I will go for next step, which is equals to 1 by 1 minus e power minus 2 pi s integration 0 to pi e power minus st sin 1t, you write like that, you write down e power minus st sin t na, sin t means sin 1t, because I have to take one formula, that is integration e power ax or at, you take at into sin bt dt, integration e power at sin bt dt, formula is e power at by a square plus b square into a sin bt minus b cos bt. So, this is the formula for, okay, this is the formula for e power at sin bt dt. Actually, this integration is in that form. So, I am writing this as 1 by 1 minus e power minus 2 pi s. Okay. So, here a is how much? A is s and b is 1. So, then e power a is s, st minus s actually, the place of a we have minus s na, AT, 18 we have minus st. So a by minus s, e power minus st by a square means minus s whole square, that becomes s square plus b square, b is 1. See, this is a and this is b you take, okay. This is a, take this is a and this is b you take. So e power minus st into a square plus b square means s square plus 1 into a sin bt means minus s, a means minus s, sin bt means sin t, minus b is 1, 1 cos bt means cos t, means cos t only, cos t only, over the limits 0 to pi, over the limits 0 to pi. So integration of e power minus st sin t dt is this. Now you put the limits 1 by 1 minus e power minus 2 pi s for upper limit. For upper limit it is going to be e power minus pi s by s square plus 1 into minus s into sin pi minus cos pi, okay, minus cos pi. For upper limit e power minus pi s by s square plus 1 into minus s sin pi minus cos pi, minus for lower limit, for lower limit e power 0, e power 0 is going to be 1. If I put t by 0, e power minus s into 0 is e power 0, e power 0 is 1. So 1 by s square plus 1 will be 1 by s square plus 1 into minus s into sin 0, sin 0 is 0. So the term is 0 minus and cos 0 is 1. So which is equals to 1 by 1 minus e power minus 2 pi s. I am just going to simplify this. Sin pi value is going to be 0, sin n pi is 0 for n is equals to 0 and all. So sin n pi is 0, sin n pi is 0 for n is equals to 1, 2 and so on. Cos n pi is equals to minus 1 whole power n. So here cos pi we have, cos pi is minus 1, minus 1 into minus plus 1. So it becomes totally the value is going to be plus 1. So e power minus pi s by s square plus 1 into 1, this total value is 1 na, this is 0, this is going to be plus 1. So 1 into this is going to be minus pi s by s square plus 1. Next minus into minus plus 1 by s square plus 1. Okay. So then you simplify this, what do you get, which is equals to 1 by 1 minus e power minus 2 pi s into 1 plus e power minus pi s by s square plus 1. Okay na? S square plus 1 is common under denominator. So you can directly add the numerators, that is e power minus pi s plus 1. So now here further simplification as 1 plus e power minus pi s by this 1 minus e power minus 2 pi s we write as 1 square minus e power minus pi s whole square you can write. E power minus 2 pi s we can write as e power minus pi s whole square, which is like a square minus b square, which is like a square minus b square is going to be 1 plus e power minus pi s, that is a plus b, into 1 minus e power minus pi s is a minus b. Okay, 1 square minus e power minus pi whole square is going to be like this. So I am writing this as 1 plus e power minus pi s into 1 minus e power minus pi s into 1 by s square is there na. So 1 by s square plus 1 I will write. So these two get cancelled. So on multiplication you will get as 1 minus e power minus pi s into s square plus 1. So this is Laplace transform of f of t, where f of t equals to what? Sin t for 0 less than t less than pi, 0 for pi less than t less than 2 pi. Okay. So Laplace, this here f of t is a periodic function with pi, with 2 pi. So likewise you can evaluate Laplace transform of periodic functions. Laplace transform of periodic functions. This is also one important problem which asked in previous year. You please, if any periodic functions are there, how you evaluate Laplace transform, you just try to learn by doing number of problems on periodic functions. It is very important. For a university examination they are asking questions on periodic functions. Find Laplace transform of periodic functions. Next one more, f of t is equal to t square is also periodic function he has provided, that is f of t plus 2. Of course it is actually not happened, but he defined like that, f of t plus 2 is equal to f of t is happened, like that he defined. Okay. So in this case t is equal to what? Periodic, t is equal to 2 and f of t equals to t square for 0 less than t less than 2. Okay. F of t plus 2 is equal to f of t means t is equal to 2 here. So apply Laplace transform. So L of f of t so 1 minus e power minus s means 2s integration 0 to 2 f of t e power minus st, f of t means t square, into dt, because so over the interval 0 to 2, defined by t square. So I took 0 to 2 directly. I am not going to split in, because there is a function which is defined totally as t square. So then 1 by 1 minus e power minus 2s. So you apply uv rule, you take this as u and this as v, integration by parts you apply, or you apply uv rule. U means t square, e power minus st integration, u differentiation you have to take, and v integration you have to take, means u into integration of v means minus e power minus st by minus s. This is the integration of e power minus st, means integration of uv dx like that is there, means here uv is taken by Eilert rule. Eilert rule we have to take u and v, the functions selection of u and v by using Eilert rule. So inverse trigonometric, inverse function, logarithmic function, algebraic, trigonometric and exponential. So according to the uv rule I have taken, this is algebraic, algebraic term. So algebraic term came first, so I took u, and this is exponential function that comes under last. So for algebraic function I have taken u, for a exponential function I am taking as v. Okay. So u into integration of v, that is e power minus st by minus s, minus t square differentiation is 2t differentiation, means uv rule you have to write u into v dash, sorry v1, I have to write the formula here, u into v1 minus u dash into v2 plus u double dash into V3, u double dash into V3, u double dash into V3 minus and so on. Here V1 is nothing but integration of V, V2 is nothing but integration of V1, and V3 is nothing but integration of V2, okay, and so on. U dash is nothing but differentiation of U. U double dash means differentiation of U dash, and so on. So this formula I am just applying. So t square integration of V is e power minus st by minus s, and t square differentiation is 2t, and e power minus st by minus s again integration is e power minus st by minus s whole square is going to be s square, okay, plus 2t differentiation 2, and e power minus st by s square again integration is going to be e power minus st by minus s cube over the limits 0 to 2. Okay. So now you take the limits, here 1 by 1 minus e power minus 2s into upper limit, when upper limit is 2 na, so 2 square is 4, e power minus 2t minus 2s by s with a negative sign, as minus is under denominator, the whole term comes under negative sign, minus 2t is 4, e power minus st means minus 2s by s square plus 2 into e power minus st by s cube. Here minus symbol is there na, minus s cube na, so minus s cube na, so it becomes minus, this term is going to be minus. Okay. So this is for upper limit, minus lower limit. For lower limit this term will be become this term become 0, and this term also become 0, this term only left, that is e power 0 is 1, that is 2 by minus s cube, 2 by minus s cube, minus 2 by s cube. Okay. So which is equals to 1 by 1 minus e power minus 2s into, you try to simplify here. So sorry, here I wrote st, here I have to write 2 now, so 2s, that is yes. Okay. So we can take e power minus 2s common from all the terms in this, in these 3 terms you can take e power minus 2s common. So if I bring e power minus 2s common, so what will be left? Minus 4 by s, minus 4 by s, even minus also you can bring it out, okay, minus 4 by s square minus 2 by s cube, okay. So minus into minus plus 2 by s cube, plus 2 by s cube. So then we can write this as 1 by 1 minus e power minus 2s into e power minus 2s by s cube. When I am taking a s cube as a LCM, by s cube it becomes minus 4 s square minus 4s minus 2 plus 2 by s cube, that by s cube I will just write outside. that by s cube I will write outside. Into s cube. Okay, that's all about further simplification. So this is the way of finding inverse means Laplace transform for the periodic functions, right? Next topic is inverse Laplace transform. Inverse Laplace transform next. These are all Laplace transform topics are covered. Now I am entering into inverse Laplace transform. So inverse Laplace transform means if L of f of t equals to f bar of s, then switch L to here, then that L switches as L inverse. That is L inverse of f bar of s becomes f of t. Laplace transform function is f bar of s, then when L switch to f bar of s becomes L inverse, inverse Laplace transform. Inverse Laplace transform of f bar of s equals to f of t. See, these are the standard formulas, standard elementary means Laplace transform of elementary functions. For all these I am just writing inverse Laplace transform. Means when I bring L this side, L inverse of n factorial by s power n plus 1, where n factorial is a constant that will come out. So L inverse of s by n means I will write L inverse of 1 by s power n plus 1. If I bring n factorial this side, t power n by n factorial. Okay. Similarly, L of e power a t equals to 1 by s minus a, then L inverse of 1 by s minus a is e power a t. L of e power minus a t equals to 1 by s plus a, then L inverse of 1 by s plus a is e power minus a t. So likewise, you can write inverse Laplace transform from Laplace transform of elementary functions. So Laplace transform of sin a t is a by s square plus a square. Then inverse Laplace transform of 1 by s square plus a square is sin a t by a. See, sin a t by a. So how means when I bring to this here, it is going to be L inverse of a by s square plus a square. Okay. So what is here left? Sin a t is left now here. Sin a t is left out right side. So where a is a constant, that a will come out from the L inverse, then 1 will be left here. So L inverse of 1 by s square plus a square, when I bring this a to this side, it becomes a sin a t by a. Okay, sin a t by a. So L inverse of 1 by s square plus a square is equal to sin a t by a. Similarly, L inverse of L of cos a t is equal to s by s square plus a square. From that L inverse of s by, so sorry here bracket should be L inverse of s by s square plus a square is equal to cos a t. L of sin h a t is equal to a by s square minus a square. Then L inverse of 1 by s square minus a square is equal to sin h a t by a. Laplace transform of cos h a t is equal to s by s square minus a square. Then L inverse of s by s square minus a square is cos h a t. Only for sin and sin a t cos h a t, whose inverse Laplace transform followed by a under denominator. Under denominator a will be followed for the inverse Laplace transforms. Okay. So that you need to observe. So these are all standard formulae under inverse Laplace transform. These standard formulae of inverse Laplace transform we evaluated from Laplace transform of standard functions. Now, so even linearity property we have learned in Laplace transform. Similarly, linearity property I am discussing. So L inverse of f bar of s is equal to f of t. Then L inverse of g bar of s is equal to g of t. Means L of f of t equals to f bar of s na. When I switch L to f bar of s, then L inverse of f bar of s becomes as f of t. That is what he is saying. So then L inverse of a into f bar of s plus b into g bar of s is going to be a into f of t plus b into g of t, okay, which is very similar to linearity property of Laplace transform. Okay. Next, let us see the problem under linearity property. first question. So L inverse of s square minus 3s plus 4 by s cube. So try to simplify this. L inverse of s square by s cube is 1 by s, minus 3 into s by s cube is 1 by s square, plus 4 by s cube, that is 1 by s cube I am writing. Just a simplified format I wrote. Okay. So which is equals to L inverse of 1 by s minus 3 into L inverse of 1 by s square plus 4 into L inverse of 1 by s cube. So this I am writing by linearity property of inverse Laplace transform. Linearity property. Linearity property of inverse Laplace transform. I have shown linearity inverse Laplace transform linear property I shown. No? So similar using this property I am just writing this. So whereas inverse Laplace transform 1 by s, what we have learned? See, inverse Laplace transform 1 by s, if I put n is equal to 0, 1 by s you will get na. So n is equal to 0 means t power 0 by 0 factorial. T power 0 is 1, 0 factorial is 1. So it is going to be 1. So then inverse Laplace transform 1 by is 1, 1 by s is 1, minus 3 into L inverse of 1 by s square is going to be t. How? See, L inverse of 1 by s power n plus 1 is equals to, what is the formula? Is equals to t power n by n factorial. Okay na? So here s square we have, means in the place of n you keep 1. So 1 by 1 factorial, t power 1 by 1 factorial is t. So that is 3t plus 4 into L inverse of 1 by s cube, you keep n by 2, that is 2 square by t square by 2 factorial, that is t square by 2, t square by 2. So 2 ones, 2 twos, which is equals to 1 minus 3t plus 2t square. Okay, 1 minus 3t plus 2t square. So this is inverse Laplace transform of this one. Similarly, we can do second one also. That is inverse Laplace transform of 3 into s square minus 2 whole square by 2 into s power 5. We can write 3 by 2 outside from inverse Laplace transform. S square minus 2 whole square is s power 4 plus 4 minus 4s square as per the expansion of a minus b whole square. Expansion of a minus b whole square, it becomes s power 4 plus a square plus b square minus 2ab, right. So again you simplify, 3 by 2 into L inverse of s power 4 by s power 5 is 1 by s plus 4 into 1 by s power 5 minus 4 into s square by s power 5 is 1 by s cube. Again by linearity property we can write this as L inverse of 1 by s plus 4 into L inverse of 1 by s power 5 minus 4 into L inverse of 1 by s cube. Okay. So which is equals to 3 by 2 into L inverse of 1 by s is 1 as we discussed, plus 4 into L inverse of 1 by s power 5. S power 5 means n is equal to 4, t power 4 by 4 factorial, that is t power 4 by 4 factorial, that is becomes 24. Okay. L inverse of 1 by s power n plus 1 means t power n by n factorial. Here n is 4, we will take t power 4 by 4 factorial, that is t power 4 by 24 minus 4 into L inverse of 1 by s cube is t square by 2 t square by 2. Now you simplify this. Now you simplify, which is equals to 3 by 2 into 1 plus 4 ones, 4 times by 6, 24 divisible by 4, 24 by 6 times, that is t power 4 by 6 minus 2t square. So this is inverse Laplace transform of 3 into s minus 2 whole square by 2s power 5. So 3 by 2 into 1 plus t power 4 by 6 minus 2t square. Okay, like this, you using linearity property by on simplification. So it's a basic problems. These are all under inverse Laplace transform. Okay. Next, so find the means here using partial fractions. Using partial fractions, very important. Mostly they are asking problems under using partial fractions. Using partial fractions, they are asking using partial fractions. How we are going to do problems under using partial fractions? So here, how we decompose means we decompose the fractions into partial fractions. How we are going to write this under partial fractions? We have 4 rules. One is for linear factors. If it is linear factors under a denominator, the given result under the denominator, if linear factors are there, so means here linear factor, that is s plus 1 and s plus 2 are linear factors. In such case, you go for a by s plus 1 plus b by s plus 2. Likewise, you split into, and which is equals to by 4 into s plus 1 into s plus 2. As linear factors, as in the denominator we have linear factors, I am splitting into a by s plus 1 plus b by s plus 2. So now we write this as a into s plus 2 plus b into s plus 1 is equals to 4. Is equals to 4. Numerator becomes a into s plus 2 into b into s plus 1. As denominator becomes s plus 1 and s plus 2, then numerators will be the alternative denominators of the numerators is going to be 4, is going to be equal to 4. So from this, if I put s is equals to, put s is equal to minus 2, if I put s is equal to minus 2, this term is going to be 0, then minus 2 plus 1 is minus 1, minus b is equal to, from this, b minus b, b is equals to, minus b is equals to 4, that is b equals to minus 4. Okay, means 4 by s plus 1, s plus 2, I have to split into partial fractions, where the factors are under linear factors, so I can use this rule. This is the first rule. Similarly, we have 4 rules that I will tell on means with respect to the problems, with respect to the cases, I will give the rules, right. So a by s plus 1 plus b by s plus 2, which is equals to 4 into s plus 1 into s plus 2. So then numerator becomes a into s plus 2 plus b into s plus 1 is going to be 4, as numerator is we have 4. Now put s is equal to 2 minus 2, then minus 2 plus 2 is 0, this a is going to be absent, then b into minus 2 plus 1 is minus b is equal to 4, that is b equals to minus 4. Similarly, put s is equals to, put s is equal to minus 1, put s is equal to minus 1, this is going to be 0, then a 3a, put s is equal to 1, 3a is equals to 4, from this a is equal to 3 by 4, 4 by 3. So then substitute in that, substitute in that. So a is equal to 4 by 3, so then it becomes a is 4 by 3 by s plus 1 plus b is minus 4 by s plus 2. okay, means the given 4 into s plus 1 into s plus 2, the given one I split it into partial fractions. So now I am taking L inverse for this. So therefore, for this I am taking L inverse. As linearity property, I will write this as L inverse of 1 by s plus 1 minus 4 into L inverse of 1 by s plus 2. Okay. So which is equals to 4 by 3 into L inverse of 1 by s plus 1 means e power minus t minus 4 into L inverse of 1 by s plus 2 means e power minus 2t. 1 by s plus a, L inverse of 1 by s plus a is e power minus at. Here a is 1, so e power minus t. 1 by s plus 2 whose L inverse Laplace transform is going to be e power minus 2t. Okay. So means you have to split into partial fractions using this, otherwise you can also write okay. So like this we can, by putting s is equal to minus 2, if I put s is equal to minus 1 you will get to 1 now, sorry, here you will get to 1, a is equal to 4, sorry, I wrote put s is equal to minus 1 plus 2 is 1a, sorry, so it is going to be 4 only, is going to be 4 only. So is going to be 4 only. It's not 4 by 3, it's not 4 by 3. We can write this as 4 into e power minus t minus e power minus 2t, sorry. Here by putting s is equal to minus 1 it becomes 1 only, sorry, by mistake I wrote 3, 1, a is equals to 4, this is going to be 0 is equal to 4. Otherwise see, even we can also do this as 4 into we split into directly, we split into partial fractions by s plus 1 minus 1 by s plus 2. It's very simple. So direct method means on analyzation, numerical analyzation, we can write directly. If you simplify this you will get this only. So without having this directly you can write and you proceed. So like that also you can go for evaluating inverse Laplace under partial fractions. Next, L inverse of, so I again have to split into partial fractions this one. So here for this case I cannot go for in this way, as here the numerator is s square plus s minus 2, so I cannot go for direct methods. So I have to split into partial fractions, s square plus s minus 2 by s into s plus 3 into s minus 2. I am splitting into whereas here all factors are linear, so I can write this as a by s plus b by s plus 3 plus c by s minus 2. Okay. So then s square plus s minus 2 is equals to, what do you get here on, means by taking numerators, a into s plus 3 into s minus 2 plus b into s minus 2 plus c into s plus 3. The numerator parts becomes like this, as a denominator, as the LCM is s into s plus 3 into s minus 2, a into s plus 3 into s minus 2 plus b into s minus 2 plus c into s plus 3, like that. Now here I have to evaluate A, B and C. So let us take, here put s is equals to, put s is equal to minus 3, put s is equal to minus 3. To evaluate of A, B and C, I am just putting s by minus 3, it is going to be 0, even this is also going to be 0, means A term is going to be 0, capital A term is going to be 0, C term is also going to be 0, only this will be left. So when I put minus 3 into minus 2, minus 5 into minus 3 plus 15. So 15b is equals to minus 3 whole square is 9, minus 3 minus 2 is minus 5, 9 minus 5 is 4. So from this b is equals to 4 by 15. Okay. When I put s is equal to minus 3, these terms A, capital A term and C containing term is going to be 0, then this term only left. So in the place of s, if I keep minus 3 into minus 3 minus 2 is minus 5, minus 5 into minus 3 is plus 15, 15b is equals to minus 3 whole square means 9 minus 3 means 6 minus 2 4, so 15, b is equal to 4 by 15. Similarly put s is equals to what, 0, you put s is equal to 0. If I put s is equal to 0, these two terms are going to be vanished, these two terms are 0, only a term will be left. So then a, s is 0 means 3a you will get, 3a is equals to minus 2 you will get. So from this a equals to minus 2 by 3, a equals to minus 2 by 3. Okay. Next, so b evaluated, b we found b and a, and c you have to find. So for that I have to make a and b 0. For that what you have to keep 0? Put s is equals to 2, put s is equal to 2. If I put s is equal to 2, this becomes 0, this becomes 0, this becomes 2 plus 3 is 5 into 2, 10, 10c is equals to, 10c is equals to 2 square is 4 plus 2, 6 minus 2, 4, 10c is equals to 4, that implies c equals to 4 by 10 which is equals to 2 by 5. So I evaluated a, b and c, then substitute. So therefore s square plus s minus 2 by s into s plus 3 into s minus 2 is equals to, a is minus 2 by 3 na, minus 2 by 3 by s plus b is 4 by 15, 4 by 15 by s plus 3 plus, and c is 2 by 5, 2 by 5 by s minus 2. Okay. Now you take inverse Laplace transform on both sides. Then you take inverse Laplace transform on both sides. So then it becomes minus 2 by 3 into L inverse of 1 by s plus 4 by 15 into L inverse of 1 by s plus 3 plus 2 by 5 into L inverse of 1 by s minus 2. So which is equals to minus 2 by 3 minus 2 by 3, L inverse of 1 by s is 1 plus 4 by 15, L inverse of 1 by s plus 3 is e power minus 3t, this is like L inverse of 1 by s plus a, that is e power minus 80, plus 2 by 5 into L inverse of 1 by s minus a is e power 80, that is e power 2t. Sorry, wait. That is e power 2t. Okay. So, this is what L inverse of, you can, if you want to, you can simplify, otherwise you can leave it, was because here. So, minus 2 by 3 into 1 is minus 2 by 3 plus 4 into e power minus 3t by 15 plus 2 into e power 2t by 5. So, this is what L inverse of what, s square plus s minus 2 by s into s plus 3 into s minus 2. Okay. Next. Next, using partial fractions, even this also we are going to do. Here, first you try to write in partial fractions 5s by 5s minus 2 by s square into s plus 2 into s minus 1. Here all are linear factors.
Wherever may be your present journey, but if you decided for your goal, whatever may be your present position, but if you opted to reach higher altitudes in the life, however may be your present duties, but if you choose to find the joy of working, whatever may be your present circumstances, but if you determined for your success. Yes, you rightly heard it. ACE online platform raises you much more than what you can think. This platform provides pre-recorded and online lectures which you can access around the clock. You can prepare for the various competitive exams like a GATE, ESC, PSUs and other state service exams, mainly in the English, Hindi and Telugu languages. Hope you'll all going to make ACE online platform as a part of your success story. ACE Online. Learn anywhere, anytime.
Right, buddies, I have seen in chart box that A is equal to 1 by 3, A is equal to 1 by 3, one student kept here, I saw in the chart box. So, when I put S is equal to 0, 0, 0, minus 2 and 3 into minus 2 is minus 6, minus 2 is equals to minus 6, minus 2, sorry, minus 2 equals to minus 6A, A is equal to 1 by 3, oh sorry ma, A is equal to 1 by 3, sorry, small 1 by 3, here 6A you will get, minus 6A you will get here, isn't it, minus 6A, here minus 2, A is equal to 1 by 3. So, A is equal to 1 by 3 means here you will get 1 by 3. here 1 by 3 1 by 3 and here 1 by 3 1 by 3 1 by 3. Sorry. So in the place of A we have 1 by 3 m, not 2 minus 2 by 3. I wrongly evaluated that. You please make it correct. A is equal to 1 by 3. So sorry for the mistake I have done. Now 5s minus 2 by s square into s plus 2 into s minus 1. This I am going to write by A by, as here linear factors and one linear factor is repeated. In such case you write A by s, B by s square plus C by s plus 2 plus D by s minus 1. Okay, all are linear factors, but one linear factor is repeated. So in such case you have to write like this. Okay, so now which is equals to A into s, wait, sorry, so here right. So now A into s into, so s plus 2 into s minus 1. When I am taking the LCM s square s as s square into s plus 2 into s minus 1, then A into s plus 2 into s minus 1 will get, plus B into, what will get, s plus 2 into s minus 1 plus C into s square, C into s square into s minus 1 plus D into s square s plus 2, D into s square s plus 2. Now in this we have numerator as 5 minus 2 and that side numerator is this. Okay, so this numerator I evaluated. Now put s is equal to 0 to evaluate A, B and C. Put s is equal to 0. This term is going to be 0. This term is going to be 0. Means A term is going to be 0. Even C term is going to be 0. D term is going to be 0. Only this will be left. S 2 into minus 1, minus 2b. Minus 2b is equals to 5 into 0 is 5 into 0 is 0, minus 2 minus 2. That equals to b equals to 1. B equals to 1. Next put s is equal to minus 2. If I put s is equal to minus 2, this term 0 and this term 0, last term is going to be 0. Okay, so then minus 2 whole square is 4, minus 2 minus 1 is minus 3, minus 3 into 4 is minus 12c. Minus 12c is equals to minus 12. So from this c is equal to 1. From this c is equal to 1. Next put s is equal to 1. If I put s is equal to 1, A term, B term and C term is going to be 0 and D term will be s is equal to 1, 1 into 3, 3D. 3D equals to 3. 5 into 1 minus 2 is 5 minus 2, that is 3. So from this D also going to be 1. Now I have to evaluate A. See, I evaluated A, B, C and D. by putting S0 is equal to 0, S is equal to minus 2, S is equal to 1. So all factors are completed. So there is no option for keeping S by any other values. So in such case you take other method is, that is for evaluating A. A is having means the combination A, for the A combination we have S cube term na, A into S square S cube term. So you take coefficient of S cube on both sides. If I take a coefficient of S cube, then what you will get? A, okay na, coefficient of S cube A plus what is here you will not get coefficient of S cube, but here you will get as C, but here you will get as D. So these are the coefficient of S cube, and here coefficient of S cube is 0. On this side no coefficient S cube term, there is no S cube term, so its coefficient is 0. Where C is equal to D is equal to 1 now, C is 1, D is 1. So C 1 plus 1 2. So then that implies A is going to be minus 2, A is going to be minus 2, that you write here. So then 5S minus 2 by S square into S plus 2 into S minus 1 is equals to, A is how much we got? Minus 2, minus 2 by S plus B, C, D all 1 na? So B is 1 by S square, C is 1 by S plus 2, and D is 1 by S minus 1, 1 by S minus 1. So this is I factor, means I split into partial fractions. I decomposed this into partial fractions. Now you take L inverse on both sides, inverse Laplace transform. If I take inverse Laplace transform on both sides, by linearity property we can write minus 2 into L inverse of 1 by S plus L inverse of 1 by S square plus L inverse of 1 by S plus 2 plus L inverse of 1 by S minus 1. So which is equals to minus 2 into 1 by S inverse Laplace transform is 1 plus inverse transform of 1 by S square is t plus L inverse of 1 by S plus 2 is e power minus 2t plus L inverse of 1 by S minus 1 is e power t. This is L inverse of 5s minus 2 by S square into S plus 2 into S minus 1. Okay. Next another question on inverse, this one, S square minus 2S minus 4 by S square plus 9 into S minus 1, because I am taking different models on partial fractions, because definitely one question is on partial fractions, which will be on different models with linear factors, with the quadratic factors, how we are going to split into partial fractions. Here I am taking S square minus 2S minus 4 by S square plus 9 into S minus 5. So here one factor is in quadratic form. So for that the numerator, the splitting of partial fractions, the numerator becomes as as plus b by s square plus 9. Okay, first rule is means if it is linear factors, you write a by plus b by that linear factors. If linear factor is repeated, then a by that factor, likewise previous sum on repeating linear factor. And here quadratic factor is there. In such case, for the respective quadratic factor in the denominator, you take as plus b in the numerator plus b by c by s minus 5, c by s minus 5. Now the numerators you take on both sides, s square plus 2s minus 4 equals to as plus b into s minus 5 plus c into s square plus 9. Okay, when I compare with the means LCM, that the numerators will get multiplied by the alternative denominators. Now to evaluate A, B and C values, you just go by put S is equal to 5, so then this term is going to be 0. So when I put S is equal to 5, this becomes 25 plus 9 is 34, 34C is equals to 25 S 5 square, put S is equal to 5, 25 plus 10, 35 minus 4, 31. So from this C is equal to 31 by 34. C is equals to 31 by 34. This is we got by C value. Now put S is equal to 0, better put S is equal to 0, what do you get? When I put S is equal to 0, A term is going to be 0 and A term is going to be 0, B means B only left here, S0 minus 5B, here this term is 0 plus 9C is equals to, when I put S is equal to 0, here you will get minus 4, right. So then minus 5B is equals to minus 4 minus 9C. C is how much? 31 by 4 na? So 31 by 4, 31 by 34. Okay, is it? When I put S is equal to 0, this becomes 0 and 0 minus 5 is minus 5, minus 5 into B is minus 5B plus this is 0, 9C is equals to, when I put S is equal to 0, this is left by minus 4. Okay. So minus 5B, so it is going to be minus 4 into, is it goes by 34 minus 9 into 31, you have to do. You have to multiply and write that one. So that is minus 5B is equals to, what is this going to be? Minus 136 na? 4 4 16 minus 136 minus 136 minus, what do you get? Minus 279 by 34. So B equals to minus of 136, this is going to be how much? 15 and this is going to be 11 and 415 by 34 into minus 5. So minus 5 get cancelled, 5 ones, 5 83s. B equals to 83 by 34. B equals to 83 by 34. Okay, is it correct? So when I put S is equal to 0, I am getting like this, where C is equal to 31 by 4, 31 by 34, correct only na? So minus 5B is equals to minus 4 into minus 9 into 31 by 34. On calculating, B is equal to 83 by 34 we are getting. Now come to C and B I evaluated by putting S is equal to 5, by putting S is equal to 0. So by putting another value for S, we don't have another option to keep in the place of S. So you compare with S square coefficient on either side, S square coefficient. So taking S square coefficients, so taking S square coefficients on both sides, what do you get? A and plus C, A plus C is equals to S square coefficient is 1 here, is equal to 1, or S coefficient you will get more, okay, S square coefficient only you take A plus C is equals to 1. So where C is equal to how much we got? Where C is equal to how much we got? 31 by 34 na? So A equals to 1 minus C, which is equals to 1 minus 31 by 34, that equals to 3 by 34. So, we evaluated A, C we evaluated, B we evaluated and A we evaluated. Simply substitute in that. Okay. So, then what do you get? S square plus 2s minus 4 by s square plus 9 s square plus 9 into s minus 5 is equals to A is how much? A is 3 by 34, 3 by 34 s plus B by 83 by 34 by s square plus 9 plus C is how much? C is 31 by 34, 31 by 34 by s minus 5. So, then which is equals to, we can take 1 by 34 common, 3 by 34 into s by s square plus 9 plus 83 by 34, that is 1 by s square plus 9 plus 31 by 34 1 by s minus 5. Like this we are splitting into s square plus 2s minus 4 by s square plus 9 into s minus 5. So, now you take inverse Laplace transform on either side. Okay. So, if you take a inverse Laplace transform on either side, on linearity property we can write this as 3 by 34 into L inverse of s by s square plus 9 plus 83 by 34 into L inverse of 1 by s square plus 9 plus 31 by 34 into L inverse of 1 by s minus 5. So, which is equals to 3 by 34, means you can bring out 1 by 34 common. So, then 3 will be inside, 3 into L inverse of s square plus 9 is cos 3t, na, 1 by s square plus 9, s by s square plus 9 plus, so I have taken 1 by 34 common, so 83 will be left. L inverse of 1 by s square plus 9 is going to be sin 3t plus 1 by 34 I took outside, so 31 will be left. So, L inverse of 1 by s minus 5 is e power 5t, So, by using standard formulas of inverse Laplace transform, I wrote those. Okay. So, this is the way of finding. So, I hope means the calculations are all correct, I hope. Okay. Next, L inverse of s square by s square plus 4 into s square plus 25. On partial fractions I took different different problems, so that you can get an idea. So, here I am going to do I am going to split into partial fractions by direct method. I am not going to use any formula here. Direct, even if possible you can apply direct rule on numerical method. Means for example, here I will say here, that example I will say here, s square by s square plus 4 into s square plus 25, na. So, which is I am writing as s square into 1 by s square plus 4 minus 1 by s square plus 25. I am writing, I am taking and splitting into. So, when I splitting into, then this denominator goes to here, na, s square plus 25 minus this goes to here, s square plus 4 on means s square plus 25 minus s square minus 4 you will get, that numerator simplification. So, s square minus s square get cancelled, 25 minus 4 is 21, but we have only one, isn't it? So once again I will write here this. So here 1 by s square plus 4 into s square plus 25 now. So which is equals to s square into 1 by s square plus 4 minus 1 by s square plus 25. If I simplify this, you will get this by 21 by that, but we have 1. So to make it balance I am dividing by 21. So now you take 1 by s square inside, s square by s square plus 4 minus s square by s square plus 25. I am splitting into partial fractions. I split it into partial fractions by numerically, direct method. So this I am writing as like this, means the greater denominator will be subtracted from small denominator. Greater denominator factor means fraction will be deducted from small denominator fraction. So then the difference, what is the difference for 25 and 4? 21. By that you divide it, you will get. So means for all cases it is not possible, some possible cases. Here that is possible, so I am applying. But the previous questions you have to apply, you have to take a by something, b by something, you apply and do. As per the partial fractions procedure you have to do. In this case you can directly apply, possible. So now 1 by 21. So here s square by s square plus 4 direct formula we do not have. So I am splitting this as s square plus 4 minus 4 by s square plus 4. Even here also minus s square plus 25 minus 25 by s square plus 25. For evaluation process I am taking like this. So which is equals to 1 by 21 into s square plus 4 by s square plus 4 is going to be 1 minus 4 by s square plus 4 minus next s square plus 25 by s square plus 25 is minus 1, and this minus into minus is going to be plus 25 by s square plus 25. Okay, this 1 and plus 1 get cancelled. So is going to be, which is equals to 1 by 21 into 25 by s square plus 5 square minus 4 by s square plus 2 square. So we can write this as 1 by 21 into 5 into 5 by s square plus 5 square minus 2 into 2 by s square plus 2 square. So this is what I split it into partial fractions. Okay, this is what this s square and all I split it into partial fractions. Okay, means s square by s square plus 4 into s square plus 25. So for this I am taking inverse Laplace transform. For this also you take inverse Laplace transform on either. So which is equals to 1 by 21 5 into L inverse of 5 by s square plus 25 means 5 square minus 2 into L inverse of 2 by s square plus 2 square. Okay, I am just split it into partial fractions. I am taking inverse Laplace transform on either side. As per the linearity property I am just writing. So which is equals to 1 by 21 into 5 into L inverse of a by s square plus a square is going to be what? Sine a by s square plus a square na. So sine 580 5 into sine 5t minus 2 into sine 2t 2 into sine 2t. So this is the way of finding L inverse of s square by s square plus 4 into s square plus 25. Okay. Even this also you can. So s by s square plus 1 into s square plus 9. We can write this as s into 1 by s square plus 1 into s square plus 9. How we did in the previous problem. Similarly, you can here. You can also do here. S into 1 by s square plus 1 means smaller denominator term I am writing here, minus bigger denominator term I am subtracting from new smaller denominator term. So then which is equals to s into 1 by s square plus 1, of course. Here I will write this as s by s square plus 1 minus s by s square plus 9. Means here you can write 1 square, here we can write 3 square. So likewise I have split it into partial fractions. The given term is split into partial fractions. Now you take L inverse on both side. Okay. So then which is equals to L inverse of s by s square plus 1 square minus L inverse of s by s square plus 3 square. Okay. So which is equals to L inverse of s by s square plus s1 square is cos t. L inverse of s by s square plus 3 square is minus cos 3t. So this is what L inverse of s by s square plus, so here 1 by 9 is required, 1 by s square plus 1 minus 1 by s square, the difference is 8 na. So 1 by 8 has to be right, 1 by 8 we have to write, 1 by 8 you have to write 1 by 8, because when I am splitting into partial fractions, the difference in the numerator will be 8, but here 1. So that will be balanced by dividing by 8 means 1 by 8. So 1 by 8 into cos t minus cos 3t is 1 by s square plus 1 into s square plus 9. So once again I am splitting into partial fractions. When I split into partial fractions, the difference between these two is going to be 8, that will become in the numerator. So to make it balance I have to divide by 8, that is s by 8 will get, I am sending s inside, so 1 by 8 will be left inside. L inverse of this is 1 by 8 into, so this 1 by 8 is common, this 1 by 8 is common, or you write like this. So 1 by 8 into L inverse of s by s square plus 1 square is cos t minus L inverse of s by s square plus 3 square is cos 3t, like this. Okay. And this one is also we can, so I will give the hint, you try this one. So here 1 by means s by s I will take outside, s by s square plus 1 into s square plus 9 into s square plus 25. So I am writing this as s by s square plus 1 I am writing outside, then the left inside will be written by 1 by s square plus 9 into s square plus 25. So which is equals to s by s square plus 1. So then I split it into partial fractions, we can write this as 1 by s square plus 9, smaller denominator term minus bigger denominator term minus 1 by s square plus 25. 25 minus 9 is 16. So that by that 16 I am dividing, because if I simplify, the numerator will rise by 16, that will be get balanced by divide by 16. So which is equals to 1 by 16. Again you send s by 16 you keep outside, s square plus 1 you send inside, then 1 by s square plus 1 into s square plus 9 minus 1 by s square plus 1 into s square plus 25. Okay, I am sending 1 by s square plus 1 inside. So that get multiply to the both terms under denominator. So which is equals to s by 16. Again I am splitting these into 1 by s square plus 1 minus 1 by s square plus 9, whose difference is by 8. So I am dividing by 8. So the simplification of these two under LCM, the numerator going to be 8, the numerator raised by 8, that will be get balanced by divide by 8. Even similarly here. So the difference between 25 plus 1, 25 and 1 is 1 by 24, means 24, that I am dividing by 1 by 24, that is 1 by s square plus 1 minus 1 by s square plus 25. Okay. Now I will send s inside, only s I will make it inside. So for that, which is equals to which is equals to which is equals to 1 by 16. Okay, 1 by 16. If I send s inside, 1 by 8 into 8 by means s by s square plus 1, s by s square plus 1 minus s by s square plus 9 minus 1 by 24 into s by s square plus 1, s by s square plus 1 minus s by s square plus 25. Okay. So this 1 means 1 square, this 3 means 3 square, and this is 1 square, 5 means 25 means 5 square, you can write like that. Na? So which is equals to, which is what, s by s square plus 1 into s square plus 9 into s square plus 25. You take L inverse on both sides. You take L inverse on both sides. So which is equals to 1 by 16 and 1 by 8 into L inverse of s by s square plus 1, 1 square, minus L inverse of s by s square plus 3 square. Okay. Minus 1 by 24 into L inverse of s by s square plus 1 square minus L inverse of s by s square plus 5 square. Right. So which is equals to 1 by 16, 1 by 8 into, this is going to be cos t, na? Cos t minus cos 3t. L inverse of s by s square plus 1 square is cos t. This becomes cos 3t minus 1 by 24 into, so this is cos t minus cos 5t. Okay. Now you try to simplify. So here for 8 and 24 LCM is 24. So 1 by 16 into 24 I am taking outside. So 8 goes to 24 means you have to multiply by 3 times. 3 cos t minus 3 cos 3t minus cos t minus into minus plus cos 5t. So which is equals to 1 by, so this is going to be 384. 16 into 24, 16 4s 64, 16 2s 32 plus 6, 384 into 3 cos t minus cos t is 2 cos t minus 3 cos t 3t plus cos 5t, cos 5t. This is L inverse of, this is L inverse of s by s square plus 1 into s square plus 9 into s square plus 25, like this. So these are all problems I have covered which are previously asked. Even this also you can, okay, you can do this by previous method. You see here 2s square minus 6s plus 5, we can split this as s minus 1 into s minus 2 into s minus 3. So all are what linear factors. You proceed by a by s minus 1 plus b by s minus 2 and c plus c by s minus 3. Okay, you proceed, which is very similar to previous one. Okay, so you proceed this you work it out, means you practice this question I am giving to you. This is okay. Next property, first shifting theorem. In Laplace transform, how we learned first shifting theorem, no? Similarly here also we can learn. Means in Laplace transform first shifting theorem, what we learned, L of e power at f of t equals to f bar of s minus a, I said na. When I bring L, means if I shift L to here, then it becomes L inverse of then it becomes L inverse of f bar of s minus a equals to e power at f of t. If it is e power minus at, if it is multiplied by e power minus at under Laplace transform, then f bar of s plus a you will get. So that implies L inverse of f bar of s plus a equals to e power minus at f of t. This is first shifting theorem. Means first shifting theorem on Laplace transform, first shifting theorem on inverse Laplace transform, right. So now we are going to evaluate this by using first shifting theorem, that is L inverse of s plus 2 by I am writing s square minus 6x plus 8 by s minus 3 whole square, s minus 3 whole square, s minus 3 whole square means s square minus 6x plus 9, but we have 8, so you deduct minus 1. L inverse of s plus 2 by this I am writing as s minus 3 whole square minus 1 is going to be s square minus 6s plus 8. Now to convert means I have to apply in first shifting inverse Laplace transform first shifting theorem, so that I am converting s terms s minus 3. So here we have s plus 2, but I am writing s minus 3, that will be get balanced by s plus 2 on adding 5 by s minus 3 whole square minus 1. Okay. So here s minus 3 is there na. So with respect to s minus 3, here see, if it is s minus a, we are having e power 80 na. Similarly s minus 3 is there means e power 3t. So e power 3t into L inverse of s plus 5 by s square minus 1 by first shifting theorem of inverse Laplace transform, by first shifting theorem of inverse Laplace transform, first shifting theorem of inverse Laplace transform. By first shifting theorem of inverse Laplace transform, right. So now again I am splitting into e power 3t L inverse of s by s square minus 1 plus 5 into L inverse of 1 by s square minus 1. I am splitting into s by s square minus 1. For the numerator, denominator will be distributed now. So in that way I am writing. So which is equals to, so e power 3t L inverse of s by s square minus 1, s square minus 1, s square minus 1 square. It is a hyperbolic function, cos ht, cos h, here 1 is 1 square now. So in the place of a we have 1 cos ht only, plus 5 into L inverse of 1 by s square minus 1 square, 1 by s square minus a by s square minus a square, that is sin ht. So therefore inverse Laplace transform of s plus 2 by s minus 3 whole square minus 1 is equals to e power 3t into cos ht plus 5 sin ht. Okay. Next, even L inverse of s power s minus y by s square plus 3s plus 2. This you work it out. Similarly, you work it out this one. You try to work it out this s minus y by s square means you can write this as s plus 1 whole square, as we have 3s but it covers only 2s plus s plus 1. Like this you arrange and try to write whole terms in s plus 1. Here I am writing this denominator as s plus 1 terms. So similarly numerator you try to write. So which is equals to s L inverse of s plus 1 minus 6 by s plus 1 whole square plus s plus 1. So which is equals to L inverse of, I am splitting into terms, s plus 1 by s plus 1 whole square plus 1. If I bring s plus 1 common, then 1 by s plus 1 plus 1 minus 6 into L inverse of, what do you write, 1 by s plus 1 whole square plus s plus 1. Isn't it? Now we can write this as e power minus t L inverse of 1 by s plus 1 by first shifting theorem. So this I have written like this. This I wrote into any L inverse, means like inverse Laplace transform terms under linearity property, minus 6 into L inverse of, means here also you can write e power minus t, where s plus 1 I shifted to s by taking e power minus t. First shifting theorem I am applying. So L inverse of 1 by s square plus s. Now, so which is equals to e power minus t L inverse of 1 by s plus 1 is again e power minus t, isn't it? S plus 1 shifted to s now, 1 by s plus 1 means e power minus t, again it is e power minus t, minus 6 into, here I have to write here L inverse, here I have to write L inverse, L inverse of 1 by s square plus 1 plus s, sorry, s square plus s. So then 6 into e power minus t, L inverse of 1 by s square plus 1 plus s, I am writing as 1 by s into s plus 1. So which becomes e power minus 2t minus 6 into e power minus t, L inverse of, again partial fractions, 1 by s minus 1 by s plus 1, directly I am writing this, because s plus 1 minus s is going to be 1 numerator, it is gets balanced. So which is equals to e power minus 2t minus 6 into e power minus t, then L inverse of 1 by s minus L inverse of 1 by s plus 1. So which is equals to e power minus 2t minus 6 into e power minus t. So L inverse of 1 by s is 1 minus L inverse of 1 by s plus 1 is again e power minus t. Now you try to simplify, e power minus 2t minus 6 into e power minus t plus 6 into e power minus 2t, which is equals to 7 e power minus 2t minus 6 e power minus t. So this is inverse Laplace transform of this by using first shifting theorem. Next, second shifting theorem. Second shifting theorem, L inverse of f bar of s equals to f of t, then L inverse of e power minus as into f bar of s. It is also drawn from second shifting theorem of Laplace transform only, okay, right. So now, so here L inverse of f bar of s is equal to f of t, then L inverse of e power as into f bar of s is going to be g of t, where g of t is nothing but u of t minus a t greater than a, and 0 for t less than a, means we can write this as g of t, we can write as f of t minus a into heaviside function h of t minus a. So this total thing we can write by g of t into f of t minus a into h of t minus a, okay, right. Now we will see one problem here. So L inverse of 1 by s square plus 1 plus e power minus pi s by s square plus 1. I split it into, with respect to denominator, I split it the numerators. So then L inverse of 1 by s square plus 1 plus L inverse of e power minus pi s into 1 by s square plus 1. As we know, L inverse of 1 by s square plus 1 is sin t. L inverse of 1 by s square plus 1 is sin t, that we know, plus here this one is like L inverse of e power minus as into f bar of s, e power minus as into f bar of s is going to be what, f of t minus a into h of t minus a is nothing but g of t, capital G of t. Okay, by second shifting theorem we can write that as f of t minus pi into h of t minus pi. So here what is f of t? So here what is f bar of s? Here f bar of s is equal to what? Here f bar of s is equal to 1 by s square plus 1. from this L inverse of f bar of s is f of t na. So f of t equals to 1 by s square plus 1 inverse Laplace transform is sin t. Sin t. So f of t is equal to sin t here. So f of t is equal to sin t, then f of t minus pi. F of t minus pi means t sin of t minus pi into h of t minus pi, because it is a Heaviside function combination. So which is equals to sin t minus sin of t. Sin of t minus pi is going to be minus sin t, okay, into h of t minus pi. So that's all. That is L inverse of 1 plus e power minus pi s by s square plus 1. So I have applied second shifting theorem here. I have applied second shifting theorem. Okay. So this is one problem under second shifting theorem. Is there any other? Change of scale property, it's very simple. So we have L of f of t in Laplace transform. We have f bar of s, then L of f of a t is equals to 1 by a f bar of s by a. So from this if I shift L to here, then L inverse of f bar of s by a equals to a into f of a t, a into f of a t. This is one. If it is L of f of t by a, that is a into f bar of as. That implies L inverse of f bar of as equals to, bring a that side, that is 1 by a f of t by a, f of t by a. Okay. So this is inverse Laplace transform.